Hello everybody, in this video we'll be discussing about speculative execution. So what is a speculative execution? It is nothing but an optimization technique in which the processor performs a series of tasks before it is prompted to in order to have the information ready if it is required at any point. So before the information is required, the processor performs a series of tasks. The processor is prompted to perform a series of tasks to get those information which may be required in the future. So this is an optimization technique which is known as speculative execution. Speculative execution uses concurrent processing and OOE to anticipate and to fetch data that might be required at a later point. It eliminates the stall experienced while waiting for appropriate instructions to arrive for the next step. So rather than wasting time for waiting for the instructions to arrive at the next step, it takes the help of OOE, that is out of order execution. So it uses those particular bandwidth without wasting any time. It also uses branch prediction to guess which instruction will most likely be needed in the near future. And it also allows data flow analysis to arrange the instructions for the best optimal execution. So the main goal of this is to reduce the total execution time and to improve the overall performance of the CPU. Okay. Next is talking about speculative execution. What exactly happens in a speculative execution is first, the branch predictor guesses which branch is most likely to be taken in the process, and then it gathers the next set of instructions associated with that branch. The next step is then it will begin executing them before it knows which of the two branches which will be exactly going to be executed. So if the branch prediction is correct, then the instructions are already lined up and there will be no execution delay. But if the branch prediction goes wrong, then the system loads the appropriate information and it proceeds those instructions. So however, accuracy rate of branch predictions are typically always about 90 to 95%. So the need to reload the new information is very less. With out-of-order execution, the pipeline stall will obviously stop the entire CPU until the issue is solved. So also a gap is created between the CPU speed and the main memory speed. So as this gap grows, the time spent waiting for the main memory to deliver information to the CPU grows. So thus increasing the overall time which will be wasted in waiting for the execution. So what happens with the speculative execution closes this gap by keeping the CPU always busy, and it will minimize the time it spends in waiting. So thus the overall performance of the system will be improved. So basically, we'll be having two types of speculative execution, that is eager execution and predictive execution. So what happens in eager execution? In eager execution means, just a minute. So eager execution is nothing but an defined by run interface where all the operations which have been formulated, which are to be executed, they will be done at the same time. That means they will be immediately executed. So this makes the things go run very smooth. It becomes very easy to get started. Okay, so when it is enabled, it gets enabled as soon as the out of order execution becomes positive. And the next one is predictive execution. What happens in predictive execution? As we have seen in the branch prediction, with the predictive execution, it makes predictions whether a branch is to be taken or not. Based on the results of the predictions, the speculative execution takes place. So over here, two types of speculative executions we have seen, eager execution and predictive execution. So if in the exam, the theory, the short note on speculative execution is been asked, you have to just explain, give the definition, and explain the two types of speculative execution. Although this question is not very frequently asked, but still you can just go through the notes. I'll share the PPT also, so you can just go through the notes or any other reference material available. But in the last 10 years, this question has not been asked. The last topic of this particular module is difference between risk and sales. Now, this is an important topic. It is asked many times, frequently asked. So, what happens in the difference between risk and CISC? CISC is a complex instruction set computers, and RISC are reduced instruction set computers. So, in the complex instruction set computers, the main emphasis, the main focus is drawn towards the hardware, whereas in this RISC processors, the main emphasis is on the software. Next point, in CISC processor, multiple instructions are there. They have multiple instruction sizes and formats. Formats are also different, sizes are also different, instructions are also different. But in RISC, the instructions of same set with few formats. So over here, the formats are very less as compared to the instructions. The formats will be less, and with that, the instructions will be there. CISC uses very less registers, RISC uses more registers. CISC has more addressing modes, RISC has lower addressing modes. CISC will use the microprogramming very extensively. In RISC, the complexity is there with the compiler because it is basically a software emphasized. Instructions take a varying amount of execution time in the RISC processor. In the CISC processor, in the RISC processor, instruction takes one cycle at a time. So over here, the execution speed will become faster as compared to CISC. In CISC, the pipelining is very difficult. In RISC, the pipelining is easy. So this is the difference between RISC and CISC processor. 5 to 6 points are minimum required. That's it. Okay, so some important questions from this particular module which are frequently asked in the exam, the difference between risk and CISC, which we have seen just now. The next is Flynn's classification, the four classified points which we have seen in the previous videos. And the last one is superscalar architecture. Superscalar architecture, the diagram is mandatory to draw. That's it. Thank you so much.